Good morning, everyone. Wednesday, May 13th. This is the last new lesson for this week. Hopefully, you did well with your moon phases yesterday. The quizzes look pretty good. Remember, if you need help from me, reach out to me through email or Messenger or Google Hangout. Send smoke signals, anything you can think of to get a hold of me, and I will be happy to help you with that stuff. Today, we're going to finish up the week talking about eclipses, which are two of the neatest phenomena that occur because of the interaction of the sun, the earth, and the moon. All right. So this starts off this section talking about kind of imagining 10,000 years ago. You're wandering around, the sun's shining, you're picking up berries or minding your herd or whatever it might be, and you'll look up and the sun starts to dim, and all of the sudden all of the sun is completely blocked out except for this ring of fire around the outside of it. Without science and without knowing what's going on, I'm guessing that would have been a pretty scary situation. And of course, that's what it was um, back then when people didn't understand exactly what was happening. Um, but that's exactly what it would look like if we had a solar eclipse. And I'm going to show you some pictures and how that works here first. So basically, what causes an eclipse? Remember on Monday I talked to you about the size, maybe it was yesterday, about the size of the moon being about 400 times smaller than the sun, but the moon is about 400 times closer than the sun, so they, from Earth, appear to be about the same size. Well, every now and then, with the orbits of those things, they line up just so the sun, the earth, and the moon are all in a straight line. And when that happens, we get an eclipse. All right. And the first kind of eclipse that we're going to talk about is a solar eclipse. Now, if you look at this picture, you can see that the moon is directly between the sun and the earth. Up here, if we have the sun and the earth, and we draw the moon directly between them, what happens is we end up with a shadow on the earth. All right. If you were located in this shadow, the darkest part of the shadow, which is called the umbra, when you look up in the sky, the moon is directly between you and the sun, and you would see a solar eclipse. Here's some pictures. Check them out. How cool would that be to look up in the sky and see that? Now, of course, even during a solar eclipse, you still need to wear protective eyewear to look at the sun. Because the light that does sneak around the edge of the moon is still terrible for your eyes. All right. So that is what a solar eclipse would look like. Keep in mind the moon covers up the surface of the sun, but it doesn't cover up the atmosphere of the sun, which you can see in this picture. There is still a lot of activity out in the atmosphere of the sun. But what a neat phenomenon that would be to see. Um, There are some areas around the shadow called the penumbra, which are actually also shadowy parts, but not nearly as dark shadows. And in the penumbra, you could see a partial eclipse because you're kind of off to the side just a little bit. So when you look up, you can see the moon covering most of the sun or part of the sun, but not all of the sun. So a total eclipse only occurs in the umbra, or the darkest part of the moon's shadow on Earth. Now, when you look at that picture, you can see that a very small area of planet Earth is actually in the umbra. If you're anywhere else on Earth, when you look up in the sky, there's no difference. The sun looks the same as it does every day. All right. Um, so it's much more rare to see a solar eclipse in person because it happens um, maybe once or twice a year and only on a very small part of planet Earth. In fact, I pulled up some information on NASA solar eclipse, and this is the schedule of the in the last 10 years, the solar eclipses and where they've occurred. We actually had one not that long ago, 2017 in North America, that could be seen, and that was pretty cool. This year, there's a total solar eclipse on December 14th. All right. Now, if I look over at this table, though, you can see that it only is going to be seen in the Pacific, a little bit of South America, and Antarctica. So you can click on these and you get to a map. So the solar eclipse this year, December 14th, the only place you could be on land on planet Earth and see it would be if you were right in this little strip right here in Argentina. Very, very small area of Earth that can see these solar eclipses, but very cool. All right. And again, why do they happen? Because the moon in its orbit is directly between the Earth and the sun. It forms a shadow, and that shadow area on Earth, the umbra, is where you can see the solar eclipse. All right. The other type of eclipse is a lunar eclipse, and that is a different situation altogether. That is when the moon is on the opposite side of the Earth from the sun, and it lines up, and the Earth's shadow completely covers the moon. All right. I'm sure I've got a picture in the book right here. There we go. Now, of course, the Earth is much bigger than the moon. And so as the moon rotates or orbits, around the Earth and it falls into the moon's shadow, we have what's called a lunar eclipse. Now, when we look at the lunar eclipse, you can see that we still have this darkest part of the shadow, the umbra. When the moon falls in that umbra, we have a lunar eclipse. The nice thing about a lunar eclipse is that anyone on the nighttime half of the Earth, so if it's dark here, for on the nighttime half of the Earth, anyone can look up and see a lunar eclipse. I've seen several of them. Maybe you've seen them because, again, they happen usually once or twice a year, where we can see them. Again, I went to NASA and I looked, and unfortunately, for 2020, there aren't any more total lunar eclipses. There are some penumbral ones, like, let's see, July 5th, where we should be able to see some of the Earth's shadow cover the moon, but not a total lunar eclipse. So we'll have to look into 2021 to see that next total lunar eclipse. But what will that look like? Here are some pictures again from a lunar eclipse. And I love this picture right here because this is the picture that, regardless of how long ago humans were around, if they looked up in the sky and saw this, this was direct evidence that the Earth was a sphere, that the Earth is round, because it shows the shadow of the Earth on the moon is obviously curved. If the Earth was flat, imagine what that shadow would look like. It would be like, a straight line going across there or something like that. All right. And as the eclipse occurs, as the moon enters the shadow, it's curved on this edge. And as the moon goes out of the shadow, you can see the curve on the opposite side. So this was evidence long ago that the Earth is round. All right. So, just to refresh, what causes these lunar eclipses and solar eclipses? A solar eclipse occurs when the moon is directly between the Earth and the sun. It casts a shadow called the umbra onto the Earth, and anyone that's in the umbra can see the solar eclipse. A lunar eclipse is when the Earth gets directly between the sun and the moon. The moon falls into the umbra, or that darkest part of the shadow, and anyone on the nighttime half of the Earth is able to see the lunar eclipse. So solar eclipse, very few people get to see them. A lunar eclipse, anyone in the nighttime half of the Earth gets to see them. So, super, super cool. All right. That's as much as we're going to talk about today. Solar eclipses and lunar eclipses. What causes them? The quiz, you're going to, it's going to be some key terms. The umbra, the penumbra, who can see them, those kinds of things. All right. So, make sure you watch the lesson. Make sure you reach out to me with any questions. Google Hangout, Google Meet, email. You get a hold of me, and I will be happy to help you understand solar and lunar eclipses. So, with that said, make sure you do your 3 quizzes for the week. I want everyone to pass this week, and finish strong. We got 1 week to go after this. All right. So, with that said, I hope you have a great rest of your day. And if you need me, reach out, and I'm here to help. We'll talk to you later.